What's up everyone, name's Philip and I'm here to help you this time to build a formation system for your RTS Godot project. So if you don't know how to do formations, and this is not specifically for the RTS project, you can use this in other projects as well. And basically I want to teach you how you can do formations. On the first part I'm going to be teaching you the basics of the formation system, and at the end you're going to have a formation system for your RTS or personal project. And on the second part we are going to a more advanced layer, and I'm going to be previewing the formation and also allowing the player to modify that formation in real time. So this tutorial is going to use parts of the project that I built on previous tutorials. Like the idea of using modules, I have a bunch of videos exclusively dedicated to that idea and that concept. And also things like the selection box and how you can move units, I have a bunch of videos on that topic as well. So I'll not be teaching any of that. This video is just about how you can build formations using modules. So that is what we're going to be doing on this video. Let's get started. Alright everyone, so let's start working on this. So first things first, let's give a brief overview of the scene. So I guess you saw this on previous tutorials, and let's see what it's currently doing. As you can see at the moment, I can select a bunch of units, and whenever I tell them to move, they are going to move towards a single position, so they all stack up. So we're going to be building from this. The first step here is going to be starting with the modules. So let me go back here. So if you were following the series, you will notice that I have hidden and changed the code here. So I just simplify it a little bit for this tutorial. There's a bunch of things here that we don't need for this tutorial, so I just chose to hide them. And I also erased a bunch of code that didn't matter for this tutorial. The first thing we're going to start with is by creating a module for the formation. So the way we are going to do this is, as you can see here, I already did that. This is our script currently. So the blank state, which is handles unit formations, and it is extending from ref counted. So one thing here that I want to show you before starting coding the formation is how I'm using this idea of modules. So if you've been following the tutorial series, I've showed a bunch of abstract concepts of how you can use modules. So as you can see here, we have a constant, which is the module list, and it's preloading the script, which is going to hold all the modules. So if you go through it, you're going to see here that I have one enum list and one list of scripts. So this is the way that I'm doing here. So if you notice here on the code, I have selection operations, module debugger, but this is the guy that you should be worried about for this tutorial. So our RTS module formations is being loaded as formation here. And we do that by accessing the module list, scripts. So if we go here, we're accessing the scripts. Then I'm going to request an enumeration for modules so we can load the final script here. So if you don't know, enumerations are like integer constants. They are defined here, so starting to 0, 1, 2, 3. So the thing that I'm doing here is actually 0 is equal to preload this script, 1 is equal to that, and we can access this through the code by calling the names here, accessing the enumeration. As you can see, this is one of the ways you can preload modules so you can use them later in code. When you type here formation dot something, we're accessing the module list, and from the module list, from the scripts, we're accessing another script, and you can call functions for it. So selection single cast. So if I go here to the module of the selection single cast. So here it is. So that is how you can use modules. So this is a pretty useful way to separate code from your main project, and it also allows you to reuse this in other codes, and you can also load modules inside modules. So you get the idea of how we are going to use modules. So that is why I have used them right here. So this was the way that I saved the module formation to be used later. We'll be calling it just formation, and I can also use modules, so for this tutorial just call it formation. So now that we understand how we are going to be using the module formation, let's now build it. So we are going to be actually building the formation system. So let's start here by creating the main function, which is actually going to return us when the formation is saw in the video. So let's start by typing here static function. So I like to use static functions inside the script because static functions forces you to not use dynamic variables. It always have to come from the arguments. So let's type here a generic function name just to begin with. This function is going to return us with a backed vector to array. So this is by design. So we want to return a vector to array with the positions for the units of the selection we're going to pass here. So by default, we are converting the 3D coordinates to 2D. And this is also to improve performance because the calculations are going to be much simpler. Only have to worry about 2 dimensions instead of 3. And also we don't need, because we don't plan to make 3D formations, we just want a top-down formation for RTS. So this is to simplify things. So now let's press enter, and I'm going to leave here a space so we can type here the arguments for the function. And this is just to organize it, so we know which argument is this first, second, etc. So what are the arguments we're going to need for this function to work properly? The first one is the destination for the formation. So we're going to need a destination to move the formation towards it, and this most likely will be the mouse position. We also need a selection array that we're going to pass for the units. So the second argument will be the selection we are using, and we are going to need it to make some calculations. And here comes also the fun part. We're going to pass some parameters to configure how this formation is going to work. So my idea is that we can change the formation with some values. So let's call formation parameters the third argument, and let's assign here some default values. So we're going to assign here 3, 1.0, and 0.0. These parameters will come clear later. So the first one I'm going to use as the visor, the second one is going to be the spread, and the third one is going to be used for rotations. So let's classify those parameters here so we know what they will be used for. So the formation size we're going to retrieve for this function itself. It's going to come with the formation units size. So we know this is an array. You can extract the size as an integer. Next, we want a formation divisor, and this is just an abstract name. You're going to see what divisor means just down here in a bit. The third argument we're going to use as a spreader for the formation, and it's pretty self-explanatory. So now let's start by doing our formation by making a average position. So what I'm going to do here is just so this error stopped. So now we need a function that's going to average the position of all the units, so we can trace that to the mouse position and do some sort of angle calculations so we know where the formation should be looking at. So let's do another function down here, which we are going to use. This function is going to return a vector2, which is going to be the average position for all the other ones. So let's type here in the comment. We want to return a snap the average to the position of an array of vectors 2. So we are going to need as arguments here a bunch of vectors 2 inside of array. So let's call this from vex. So the first thing is to sum all the vectors inside that array. So let's create a new variable, which we are going to be used to return it later. Next, we want to iterate through the array. So for each vector2 position in the array, so from vex2, we want to add all of that inside to our variable. So we want to grab our variable, summon vec2, and keep adding those vector2 positions. So this is the way that we can get an average for the 2D position. We sum all the positions, then later we divide by its size. So we can have an average position for all those given. So the next step here should be for us to return that value as a vector2. So let's return here our sum vec2 divided by from vector2 size as vector2. So we make sure this is going to be a vector2. And we also want to snap this. So this is just something I like to do. I want to snap the vector2 to not give that broken value. So let's just round this value a little bit so it doesn't come with broken numbers if you ever need to debug or something. And if you wanted, you can just comment that out. We're going to pass an array of vectors 2, which we're going to sum all of them together inside this variable, and later we are going to divide all of those vectors for their size. This in turn will return you with an average position for that. So if you ever want to calculate an average position for a couple of given positions, this is one of the ways you can do it. So now let's go back here to our formation code, and let's calculate our current unit average position. So for the average position of those units, let's create a new variable, and this is going to be an array of vectors too. So this is going to come defined as an array by default. So now here's the thing. Let's say that for each unit inside our formation unit, so inside the selection we have, let's append the current units to the position with that unit's position vector too. So let's create a new vector too. And we're going to grab the unit global position. And here what we can do is, let me see if this works. I can say that unit is a node 3D. So when I type unit here, it allows me to type, hey, it works. So you can cast a object type here and the auto-completion code works here. So I want the global position on the X, and for the Y coordinates, we want the unit global position Z. So let me just break this down so it looks a little more clear. So for each unit, we want to append a new value here, which is going to be a vector 2. And for the X value, we want the global position X, and for the Y value, we want the global position Z. So this is a default way that you are going to convert the top coordinates of a 3D object to a 2D coordinate system. You usually use the X and Z. Y is the height position, which we don't care for this code. So now that we have this, we need to get the average position. We already made the function for that. So the current unit position center is going to be our average 2D position, which is using our current units 2D position array. So just by using this, we're going to be getting a center position for all the selection units, and we're going to use that for angle calculations just now. So why did we need the average position of the current units? Because now we are going to calculate an angle for the formation rotation. There's a bunch of ways to do this. This is one of the ways that I chose to do so it becomes clear. Primarily, rotations inside Godot are not using degrees, they are using radians. And the way that I did this code is so we can use 0 to 360 rotations. And this is the way that I did. So I'm going to be doing a bunch of conversions so that we can have the 0 to 3060 degrees. And we can use that to rotate it later as a radian back. So let's create a new variable, which is going to be a float. And this is going to be an angle to a position in radians. And we are going to use the current units to the position center with the function angle to points. And another vector 2 is going to be our formation destination, which, if you remember, is the first argument for our function. So rotations inside Godot, there's a bunch of different functions that can confuse you if you don't know what you're doing. So angle to points is somewhat different from angle to functions and also from the function angle. So you see right here we have 3 functions for angle. So each one of those returns a different thing. So I don't know if I should be doing a tutorial about this because rotations inside Godot can get you confused if you don't know how they work. So I like to use angle to point because it returns the line connecting 2 points in the x-axis in radians. There's a couple ways of calculating rotations. I'm using the center of the unit formations against the formation destination to get the basic angle. So let's convert that angle to a degree position. So let me tell you what I mean. So here we have a new variable, which is angle to position in degrees. So I'm going to do a couple of things here and see if you can follow and try to understand it. First, let's convert the radian values we got previously to degrees. So radians to degree is a function that you can convert the radian values to degrees. And you can see here what that looks like. So let's convert our angle to position in radians to degrees. Next, we want to remap this to 0 and 36 degrees. And one of the ways I found you can do that is by using the remap function. So we can remap those functions to some values here. So I can actually simplify this a little bit by doing an enter here so it can be more readable. So the first value here is the value we want to remap. The second is where it starts from. We want to start for 180 degrees. The next one we want to stop is at 180 degrees, and we want to remap that to 0 to 3060. So it's basically saying you remap the angle to position radians from 180 to 180 to 0 and 3060. So we are remapping the value so we can have it 0 to 3060 degrees. So now there's something else that I want. I also want to snap this value so we can have a rounded value. So let's snap. So now that we have converted this, let me go back and close everything together so we can see what we're working with. So I want to snap this value to an integer, so I can do snap it. And this is the variant, and the argument I want to snap is just 1. So this is going to remap this value here, which is the remap from radian to degrees for 0 to 3060 to 1s. So snap it basically is going to mean you can only use 1 digit. So if we ever have broken values, it's going to be rounded to at least 1 degree. So I just do that. Next, I want to reduce here a formation parameter, which is going to be the third parameter. So it starts counting to 0. So 0 is 1, 1 is 2, and 3 is 2 because it starts counting for 0. So the third argument is going to be used to calculate the angle to position, and you're going to see why this is required if you want to do that angle switch thing. So finally, after everything we have done, we need to convert this value back to radians. And I just wanted to simplify that through another variable so we can easily use it later inside the code. So I'm going to be doing another variable here, which is the formation angle radian. The formation angle radian is going to be equal to our degree values back to radians, which is the angle to position in degrees. So all of this code is going to basically get us an angle in degrees from 0 to 3060 back to radians from the current unit position center towards the mouse position, which is going to be the formation destination most likely. So this is the way you can calculate the angle we are going to be using to rotate the formation. So now we are going to be talking about the formation itself. So let's create some parameters here. This is just so the code stays clear. If I wanted the code more optimized, I can reduce the amount of variables here, but I think understanding the code is more important than performance in this case. But if you wanted, you can also change the code later after you understand how it works. So the first variable we're going to be creating here is a divisor. And we already have that from the formation divisor, which is a parameter. From the formation parameters, argument 0 as an integer. So the first argument we're going to pass for the array parameters is going to be used down here. Next, what we want is a horizontal size for the formation. So we want to divide the formation size by the divisor so we can have a horizontal size for the formation itself. Float formation size, because by default it is an integer, and when you try to divide it, it's not going to work. So we need to convert that to float so we can have those remain decimals. We're going to divide that by the divisor, and this in turn we are going to seal that value in an integer fashion. So this function here is the equivalent of seal to return an integer. So if you ever used seal, it runs a value upwards towards positive infinity. And the difference between that is that CI rounds that, but it returns the smallest whole number that is not less, which is a type version safe return an integer. So this is something we want. We want the horizontal size of the formation. So how many units are going to compose the horizontal stretch of the formation? This is the value that is going to determine that. Next, we want the vertical size. So let's type here. The vertical size of the formation is going to be equal to the divisor. So this is the part that the algorithm of your formation steps in. So everything besides that you can use for every formation you want. But here the structure of the code is going to be specifically for this type of formation. So if you ever want to do another formation type, probably you're going to change everything down here below. So this was the way that I found to create that type of formation. But if you ever want to do a round formation, another type of square formation, the code that you're going to come up down here is going to be completely different. So if you want to do this type of formation, this is the code that I'm using. Next, I want to save here the spread of the formation as a float, which is already defined, which is the formation spread. So this is the spread amount for each point for the formation. And the formation divisor is going to determine how many units are going to belong in the formation. Then next, let's start by making the formation itself. So this is the algorithm that I come up to make the formation. So let's start by creating a blank variable that's going to hold our formation positions, so we can return that later inside the code down below. So at the end of this code, we can return this down here, and we can forcibly give it a cast to return this as a vector2 array, so we can use it later to iterate to the selection of units. I'm going to be needing here a iterator for the horizontal formation. So for that, I'm going to be called h with I. So this is going to be iterator for the horizontal, and we need another one for the vertical. So this is the way that I'm calculating it. So we're going to start by saying that for every unit in the formation, we're going to say that, so I'm building this formation kind of from the middle on the horizontal plane. So we're going to start by saying, let's create a new variable that's going to be our h-swapper, which is going to be an integer. I'm going to start with it as 1. And we can basically switch it later. So while our v iterator for the vertical is less than our vertical size, so we want to already break this loop, so it's not a good idea to leave open loops. It can freeze your game. So we're going to break this loop already by just adding another value to the y coordinates. And also I want to reset the horizontal calculations, so you're going to see why in just a second. So while our vertical size is not being reached, we want to do this. But also I want to do another while loop that's going to work to build the formation on the horizontal plane. So here we are building the formation first vertically, then next we are building it horizontally. So that's why we have nested loops here. So next we want, while the horizontal iterator is less than our horizontal size, we want to do something. And the first thing I'm going to code here is to break that loop, which is going to be adding a 1 to the iterator. First, I want to keep inverting our h-swapper. So our h-swapper, which is 1, is going to be equal as itself in a negative format. So there's a bunch of ways you can do this. This is also another way is if you multiply this by -1, this is going to be almost the same thing, but I kind of wanted to just do this. Then next we want to create the formation position itself. So let's create a new variable here, which is going to be our formation position, and this is going to be a vector2 array, which we are going to build just in a moment here. So the x position of the formation is going to be equal to our spread. So this is going to determine the space between the formations, multiplied by our iterator in the horizontal plane, and this is going to be multiplied by our h-swapper. So this should take care of the formation for the horizontal plane. Now for the vertical value on the y-coordinate of this vector2, we're going to do simply a spread multiplied by our vertical iterator. So with this, we already have the formation itself. This is the code that basically does the formation. The last thing we want to do here is to append that. So let me close the vector2 here, so have more space. And let's say that our formation positions, so this is the way we started out of the loop, so we are returning that later. We're going to append this value here, so we know that is for to be used for the units later. So this is going to be our formation destination. So this position here is calculated relatively, so we can add that to the formation destination. So if you remember, the formation destination most likely is going to be the mouse coordinates for the player or some code for the AI we are going to make. But we want to be using as a base coordinate, so the anchor for the formation system is going to be the destination. Next, we want to add the formation position we just built it. So if you see right here, this is the formation position, and we want to add that to the formation position. So we are moving this to the mouse position. So this by itself should already work. So finally, we want to rotate this formation. So we do rotate it through the formation angle radian. And voila! This is all you need for the formation code itself. We are just finished. So So I plan to do other types of formation in the future, but this should give you a great idea of how to start your formation algorithm. So we now just have finished building the formation module, and this is everything you need to do that formation is saw in the video. So let's go back to our play interface, and here I'm going to be needing to create 3 new variables. So let me just put them right here. So we want the first one to be the formation divisor, which is going to be an integer and it's going to be 3 by default, and I can change that later. The second one is going to be our formation spread value, which is a float, which by default is 1.0. And a third one, which is be our formation rotation, which is going to be also a float value, which is going to represent degrees. So these 3 new codes. So now I want to use a setGet to clamp these values. So we can do this simply by doing another open dots there and using sets, and you can also pass here a new value, and we can say that the formation divisor is going to be equal to a clamped version through an integer of that, which is going to be of the new value to 1 and 10. So clamp, if you don't know, is going to limit the value to a given one, and here clamp with a y is going to clamp the value to return an integer. So it's basically saying from this value clamp to the mean and maximum. And we want to set a limit to 1 through 10. And you're going to see why we're doing this in just a second. So I want to do that as well for the formation spread. But this is going to be a float value. So I want to clamp the new value through 0.5 to 3.0. And the third one, we don't need to clamp it because you're going to see how we're going to do the code. So basically, we created 3 new variables to be inside the play interface. So why did I create them on here, defined on the object, instead of define them inside of the functions? Because we want to save these variables. Because if you want to change the formation, we need to store them somewhere, and we are storing them in the player interface code. So we're going to use them to apply the formation itself. So next, we're going to build a new function here, which is going to move our selection towards somewhere as a formation. And this function is going to need somewhere to move the formation to, so that is why we are passing a vector to here. And this function is not going to return nothing, so void. So let's first save our selection size, which is going to be an integer, which comes from the selection size. And selection is a variable defined on our player interface, which is an array which will have the unit selected at the moment. So that is from other tutorials. So the next thing we're going to do here is say that we're only going to use this if the selection size is higher than 1. So if for whatever reason we'll call this function using only a single unit, is not going to work. So we can do that by saying if the selection size is higher than 1. So if this works with units, but let's say you have buildings selected, you have to come up with another type of gates to filter only movable units, etc. So for now, we only are working with units, so we can safely do selection size higher than 1. We'll simplify this condition. So let's request our formation positions. So we can do that by saying our formation positions are going to be a packed vector to array, and they are going to come up from our module formation. And if you type dot here, you can see that we have the 2 functions we created inside the module. So this is the power of using modules. Something we define outside of that script is now being inserted in this code just through the definition here. I love modules, man. I always wanted to do this. And until they come up with an official way to do traits inside Godot, this is the way that I found to do it. So you can reuse code pretty much the way you want. So let's simplify this by putting a space here. And let's see, the first argument is the formation destination. So we want to move them to where to, which is the argument for this function. Then let's see, the next argument is which units you're going to move. It's basically our selection. And the third one is the formation parameters, which is a unknown variant. So we know from the module formations how it's supposed to work. We want the divisor to be the first parameter, the spread the second one, and the rotations to be the third one. So we can pass here the variables we just created. So the formation divisor is the first one, the second one is the formation spread, and the third one is the formation rotation. So this code here, we're going to be calling it multiple times throughout the script, and the structure will be the same one as you're seeing here. So this should return us with the formation positions to our units. So now we basically have to iterate through the units to see where we are going. So we can simply do let's create first a iterator here to help us and define as 0. So for every unit inside our selection, we're going to be requesting a position. And this is because the code for our units is using vector3. So we can actually, if you didn't follow the code from our previous tutorial with the new navigation system, check that out. This is pretty important stuff. We use a unit path new to generate a new navigation system, and for that tutorial I used a vector3 position. So you can convert this to a vector2 position, so we can work with that. But I'm going to use, as the function is right here, so I'm going to generate a new position vector, so we can use with that function from the unit itself. So we're going to create a new vector3 from the formation position. So if you remember, the formation position is working with a 2D vector for the X and Y position. So if you see here the basis, that's what we are going to do. So the first one is our formation position on the Y.X position. So we are using the iterator here to grab the formation position from the module formations. Also, let's add here on something very important as well for this loop, is to increase our iterator by 1 here, so we can keep iterating. So the first value for the vector, the X value for the vector3, is going to be our X position for the 2D vector2 for the formation. The second one I want to grab for the unit position itself. So this is the stuff that we can remove it later. So just as a safe precaution, we're going to say that the destination to move the units is going to be, its height destination is going to be the same as its position. So just we are safe. And next we want to add the Z position. It's going to be our formation position, Y position. So this is quite important. Here we're not exactly using Y coordinates. This is the Z coordinates for our formation because we are defining it as a vector 2. So this can look confusing, but it's just using vector 2 as a structure. So actually it's X and Z position here for the vector 3. So now we already have a new position, so we can pass that up. So what we are going to do here is say that to our unit to create a new path. So if you go back to our units are using this script here. We're going to just copy this function here and just put it right here. And we're going to say that for the units to move to this new position. Now this is not a safe way to do it, because if your unit doesn't have this function, this is going to break your code. So later I plan to add some stuff here that is going to make sure that this unit can move, and we can do this by requesting a object type from this unit, and there's a bunch of stuff we can do. For now, for the simplicity of the tutorial, we're going to just use this straight directly code here. So if you have a bug with this, maybe your unit doesn't have this function. So just to keep in mind. And as always, I forgot something here, that size is a function for the array. So there we go. Now this function is going to move our selection to a given destination as a formation. So there we go. We can now use this code to say that our selection is going to move someplace we want. So now if we go back here, we already built the function. We can go to our input states. And for the idle state here, let's say that we release the right mouse click position. We're going to, so let's go through this code. If our selection is not empty, we want to, and I'm going to come up with why this is the case here in just a second. So we are going to define some vector here, 0. We're going to raycast something from the camera position to the mouse position, so we know where we want to move. The coordinates for that raycast position you can get right with this. So this is the function that returns an intersect array for the physics direct space state. And if there is a collision with some mesh, you're going to get a result position. And you can see this follows on previous tutorials. There's a bunch of things that we can get for a intersect array code. So I showed this on previous tutorials, how you can work with that. So if that is the case, then we're going to get a mouse raycast position hit. And if that position is not 0, because if we did not found the position is going to return 0, so if those coordinates are valid, I'm going to be accessing a node here and doing a couple of things here, and I'm going to show what those are in just a second. So this unit NY move order player here is the nodes that I'm using to the player interface animation. So if you saw on previous tutorials, and it should be this guy here. So if I come up here on the center, if I hide the building placer, which was from previous tutorial, and you can see here we have a move order. So I don't know if this is going to show up. And as you can see, it's just a simple animation to move that. So I'm calling this object interface order through the animation player. On here, whenever we release the right mouse click, I am telling that animation to stop, so it resets back to frame 0. Then I'm telling it to play that animation you saw. Then I am simply moving that 3D node, so the node that is playing the interface order. So the guy that you're placing here. So let me just do a loop here. I am moving this to the position we wanted. So that is how I am doing it in code. Let me disable the loop there. So I'm moving that 3D graphic position to some place, which is the mouse raycast position. So wherever the player right mouse click, we project the raycast where it collided. Then next we are creating a 2D position here, so we can use for the function we just built. So this was the way that I was moving the units before. I was just requesting a new path to the mouse position, which is what you saw wherever we right mouse click somewhere. So wherever we right mouse click position did this animation stuff. And that is how it works by you requesting a new path to our RTS unit, which is this code right here. So now we should be able to delete this, and I can also actually comment this and just say selection, move as formation, where do you want to our goal in the 2D plane. So just by doing this, we are requesting this function with a given goal, which is the mouse position. This function is going to request positions from the formation module and tell them to move towards that position. And this is how we build that position and the formation module we just built. So just by doing that with our play interface, whenever we release the mouse right click, we're going to run this function after everything here. Guess what? Your formation is already done. So just by doing that, if we run our project here, you can see that we already are using the formation code. So this is how you use it. So as you can see, the formation code already works. So the angle for the formation is calculating from the angle of the middle of the 2D units. So if you see, I right click my mouse, I'm not going to move my mouse, you can see that it's right close to the center of the units. So whenever we right click here, from the center of the units to the mouse, we grab an angle so we can rotate the formation. And you can see something interesting here. If I go back to my module for the RTS formation, and I just comment out the part where I rotate the formation, you're going to see something pretty interesting here. The formation is not going to rotate whatsoever now. And you're going to see how they are working behind the scenes. So this is how the formation is being built with that code. You can see they are sticking up, but they are not rotating anymore. The formation is fixed. So that is how you can manipulate the formation to your liking, just by changing how the code is processed here. So this is how you are rotating all the formation by just the angle red, which is this bit of code here. So if you wanted, you could stop the project right here. You already have a working formation, which is great. And you can change the code to your liking, and you can use my code as a basis for this. So pretty awesome stuff. However, I'm going to go a step further here. I want to preview the formation, so the player must know where the units are going to end up. And I also want to configure the formation itself. So I want to set up where the player wants the units. And I also want to change some parameters. So I'm going to continue this tutorial and show you how we can do that. So that's all for this video. I'll see you guys on the next part. Bye for now.